Welcome back to Mr. Gard's Maths Lessons. Operations with decimals is what we're looking at today. We're going to be looking at adding and subtracting decimals, multiplying decimals, dividing decimals, and then multiplying and dividing by powers of 10. So we're going to have a look at the green section first, and we're going to work our way through. One of the key attributes that I find with my maths is that setting out is crucial, particularly when you're going to be using sort of long algorithms. Algorithms are kind of this sort of setting out. It's imperative that you have everything lined up correctly to avoid making any simple mistakes. I like to always work from the decimal point. I have my decimals lined up. You can see that I kind of have these columns that you may have seen when you're a little kid, but we don't use so much as we get a bit older. Now, when we're adding numbers, we always start from the right. So we look at the smallest place values. So where this 8 and 4 are the 100ths. So we're going to add those together. This should all be pretty straightforward. I'm going to go through it relatively quickly. So 8 plus 4 is 12. So I'll put the 2 down, carry the 1 into the tenths column. Now I have 3 plus 3, 6 point. Now I've done that relatively quickly, but you see the general idea. Just ensure that everything is lined up correctly. You'll also notice that I like to leave quite big spaces between my numbers. It allows me to put in my carrying of those numbers and make it really clear. These numbers up here gives me plenty of room so I don't make any simple mistakes. Similarly, when we're doing subtraction, start again from the right hand side. So I've sort of put in a tricky one here just to refresh ourselves. 7 minus 9 is not 2. You can't have 7 minus 9 unless you go into the negatives. So we need to borrow. Ooh, can we borrow from a 0? No, so that also needs to borrow. So that becomes 8, that becomes 10. Now I can borrow from a 10, make that a 9, give that a 1. Now I've got 17 minus 9 is 8, 9 minus 2 is 7, decimal point, 8 minus 3 is 5, and 1, 15.78. Nothing particularly new there. Right, multiplying decimals. Let's get my purple pen. Right, as I've written here, start by ignoring the decimals. Solve the multiplication problem. So assume this one is 573 multiplied by 86. Pretend there are no decimal places there. So I'm going to rewrite it. 573. Again, note how much I have spaced out the numbers. Right, now we treat it like a normal multiplication problem. I like to draw some little lines so that I know what I've multiplied together. So 6 times 3 is 18, carry the 1. 6 times 7 is 2, so I'll make that 43 because we're using the little 1 up the top, and 6 times 5 is 30 plus 4, 34. Magic 0, not really very magic. 8 times 3 or 80 times 3 is 24, carry the 2. 8 times 7, 6 plus 2, 8, carry the 5. 8 times 5, 45. Now I add those together. 8, 7, 12, 49,278. Now, this is where we now need to use our next step. Obviously, 5.73 times 8.6 is not 49,000. So there's two ways of doing this. There's kind of a rough estimate way, which is if I was to round 5.73 and 8.6, I'd have something like 6 times 9 or 5 times 8. So we're looking at 5 times 8 is 40, 6 times 9 is 54, so it's going to be somewhere around that mark. Now, if you look at the numbers we have, is it likely to be 4.9278, 49.278, 492? You might be able to get what the answers are likely to be. The accurate way of doing it, though, is we look at how many decimal places there are, or how many numbers after each decimal. So in this case, there were 3, 7, 3, and 6. So what we then do is we count the decimal places, and the answer is 49.278, as we sort of predicted, because 5 times 8 is 40, and 6 times 9 is 54, so it was somewhere in that range. So there's two ways of doing it, and the accurate way is count up how many decimal numbers there are after the decimal place. We're now going to have a look at multiplying and dividing by powers of 10. So you may have seen this before. We need to move the decimal place, it's kind of a saying, a number of positions when it's multiplied by 10, 100, 1000, 10,000, and so on. The number of places that we move it is dependent on how many zeros there are. I'll use a different color. So in this question, there are 2 zeros. It's times 100. That gives us our clue that we need to move the decimal place 2 positions. Now, the question is, do we move them left? Do we move the decimal place left, or do we move it right? You can just try and remember that if you multiply it, you move it to the right. If you divide it, you move it to the left. Or you can think about it practically. If I have 24 and I multiply it by 100, the number's getting bigger. It's going to be around 2,400. So I'm going to move it to the right 2 places. 1, 2. My new answer then is 2,463.1, because I've moved that decimal place to the right 2 positions. Likewise, on this second question, I'm dividing by 10. I count how many zeros there are, and then this time I'm going to move it to the left because I'm actually making this number smaller. So now my new answer is 36.82. If the question was something like, let's use the same example, 0.2, but instead of 10, it was actually 20, we can undergo the same process. I would first, again, count how many zeros there are, move the decimal place. Now I've got 36.82, but I've only divided it by 10 so far, so I still need to divide it by 2. And then I'm going to get 18.41 because that's been divided by 2. So if I had the problem where it was multiplying by 300, I would multiply it by 100 and then multiply it by 3. Finally, dividing decimals. So as I've written, the divisor must always be a whole number. The divisor is the second number, the number that you're dividing it by. You do this by multiplying both numbers by the same power of 10. So what I mean by that is we need to get this 0.4 to be a whole number. Now I could multiply it by, 20. No, that wouldn't work. 25. But a simple one is to multiply by 10. If I multiply by 10, 0.4 times 10 is 4. But what I have to do to the other side is also multiply it by 10. So we're going to move that decimal place one position to make it 257.8 divided by 4. Then we can use our division algorithm. So how many times will 4 fit into 257.8? Let's work that out quickly. So 4 is into 25, goes 6 times with a remainder of 1. 4 into 17 goes 4 times with a remainder of 1. 4 is into 18. Don't forget my decimal. Now I can always add an extra 0 because that doesn't actually change the number. 4 into 20 goes 5. So my answer there is 64.45. Now because I multiplied both numbers by 10, that 64.45 doesn't change because I can fit 64.45 lots of 0.4 into 25.78. Hopefully that makes some sense. Remember, the crux of that one is to get the divisor to be a whole number. So if it was, let's just do another example of 3.2 divided by 0.02. In order to get this number on the right, the divisor, to be a whole number, we need to multiply it by 2 positions, so 2 lots of 0, 100. So we need to multiply both sides by 100. We're going to have 320 divided by 2, and I'm not going to use the algorithm because I know that is 160. Hopefully that's made a little bit of sense to you, and remember, whatever you do, set your work out really neatly, really clearly, and you're unlikely to make a mistake. Thank you for listening.